Hi everyone, my name is Giovanni, and today I would like to show you the project that I have been working on this semester. One that explore how machine learning can help us predict cryptocurrency scam before they happen. With that said, let me give you like a quick preview of what we are talking about. So, most crypto scam get analyzed after it's too late. But imagine if we could see the sign before a collapse. Like, for example, just by looking at the price data. That was the real challenge of this project. Not just classifying rug pull after the fact, but asking whether we could predict them early using models that understand pattern over time. So, a rug pull happen when a project's founders suddenly disappear. So, taking all the invested founder with them. It is basically the digital equivalent of someone built trust and then vanish. So, rug pull don't just cause financial losses, they damage the entire ecosystem by making people afraid to invest at all. So, that is why developing predictive tools is critical. So to do that, I used a dataset that were developed by my teammate Buckley. He selected 48 known rug pools and matched them with 48 legitimate tokens. Then he extracted financial features that describe each token's behavior in the day leading up to the crash. So things like, for example, 30 days volatility, maximum drawdown, 7-day momentum, and parameters from the Easton stochastic volatility model. So this part of the pipeline was essential because it gave me the input signals needed to train and evaluate the model. So my job started once the dataset and the features were ready. I also added a couple of extra features while working on the models that I saw worked well with the models. But anyway, I built and tuned multiple machine learning models to classify whether a token was a rug pull. Then I moved one step features by building temporal models to see whether we could catch the rug pull before it happened, so using the sequence of daily data over time. So this is where GRU and LSTM models came in. But I began with standard classifiers, so classifier like logistic regression, random forest, MLP, support vector machine, and so on. So these models don't work on time series. They take a fixed snapshot of futures and learn how to separate scam token from legit ones. And surprisingly, some models like logistic regression and MLP reached AUC equal to 1. That is rare, and it showed that scam behavior leaves very strong pattern in the pre-event data. So to understand why the models were working, I used SHAP analysis. SHAP tell you which features most influence a model's decision. So across almost all the classifiers, average volume and 7 days volatility were the strongest predictors. So high volume and low volatility are often red flags, suggesting artificially stabilized token means to attract buyers. And before diving into more complex models, I explored the structure of the dataset using PCA and TSNE. PCA showed a strong outlier. So one token with extremely high volume, um, which distorted the data. And so that suggests that we need log transformation or outlier handling. And then I use it also TSNE, which is better at revealing non-linear patterns. So it clearly showed cluster of rug pools overlapping only slightly with legit tokens. So this confirmed that the problem is not entirely random. So it has a structure, and that structure can be learned. But here's the problem with standard classifier, basically, because they only predict after the event has already happened. So what if we want a model that can raise a red flag a few days before the collapse? That is when I started to build temporal sequence models like GRU and LSTM. So GRU is a simplified version of recurrent neural networks. I fed it sequence of 30 days of price, return, and volume. And so the model produced daily risk scores, and I marked the last 5 days before each no rug pull as the danger zone. And so grew. We saw that grew worked, but its performance was limited. We can see here, for example, an AURC of 0.48 and an AP of 0.46. So still, it was fast and efficient, but it's more like ideal for low latency applications. But LSTM added memory to the equation, so it doesn't just look at recent history. It remember also gradual patterns. So this model outperformed grew significantly. Like we can see AU or C that is equal to 0.80 and AP is equal to 0.69. So it raised alerts several days before the collapse with much better precision and fewer false positive. So for early warning systems, this kind of performance is critical, and LSTM is definitely better. And of course, this is not a finished product. One big challenge is that I only have 48 scans tokens, and I didn't have on-chain data or social media sentiment. But even so, the results are very promising, really. And with live feeds and a better data pipeline, we could build a real-time dashboard that flags suspicious tokens before the damage is done. And so, having said that, I want to conclude by saying that people think that rug pull are unpredictable, but these projects show that it's not true. The signal exists. We just need the right models to read them. And if we want crypto to be safer for everyone, we cannot just look backwards. We have to build tools that look forward. And this works lays the groundwork for those tools. And so, having said that, I would like to thank you for your attention. And this is all for today.